So this problem that we're going to look at is we're going to have to predict the products of the following acid-base reactions. And we're going to have to draw the curved arrows to show the formation and breaking of those bonds. So the first one we're going to look at is not the acid-base sort of reactions you're used to seeing in general chemistry. This is a Lewis acid-base reaction. The reason why we know that is neither of our compounds have an acidic hydrogen or a proton that is acidic. Usually, you know if you have a um, Bronsted acid-base reaction when you have a hydrogen on a heteroatom, a non-carbon atom. And here we do not have that. So we know that this is actually going to be a Lewis acid-base reaction. The Lewis acid is going to um, accept electron pairs, whereas the Lewis base is going to donate an electron pair. And we can see that in these two structures, the oxygen is what has the lone pairs of electrons. So it's going to be our Lewis base. And our Lewis acid is going to be the trifluoroborane or boron trifluoride because it is electron deficient. And so what's going to happen is those electrons from the oxygen are going to bond to the boron. And what we get is one of our lone pairs goes away, so we just have one left. This arrow here is showing the bond forming between oxygen and boron, so I'm going to draw that. And then the boron is still bonded to 3 fluorines. And in this scenario, notice that the oxygen is losing electrons when that bond forms. We're giving up those electrons. And so it's going to end up being a positive charge because it lost electrons. And then the boron is accepting electrons. It is gaining electrons. So it's going to be a negative charge. And that is a Lewis acid-base reaction. Know whenever you do a reaction, the charges on the left must equal the charges on the right. This is neutral overall. And on the right side, even though we have a positive and a negative, those end up being neutral when you add them together. So this is the first reaction. The second one, we have HI with this acetone molecule. Now, this is a Bronsted acid because it is a hydrogen on a heteroatom. It can donate that hydrogen. It is a fairly acidic hydrogen. Over here, we have our base. And again, bases have electron pairs in which they can give up electrons. So our base is going to be our acetone, and our acid is going to be our hydroiodic acid. Now, usually when you show curved arrows, if you're losing an atom or if you're breaking a bond, you need to show that bond. So in a case like this, I want to separate this into the hydrogen iodine bond. That way, when I show the bond forming between oxygen and hydrogen, I can also show the bond breaking between the hydrogen and iodine. Now, in the previous scenario, we didn't break a bond when a bond was formed. That is because when the oxygen bonded to the boron, we formed an octet and there's no reason to lose any bonds. In this scenario, when you bond to that hydrogen has too many bonds and it needs to lose one by giving its electrons to the iodine. And if you follow your curved arrows, that is the bond forming between oxygen and hydrogen. It used a lone pair from the oxygen, so we only have one remaining. And the other arrow down here is showing the breaking of that iodine hydrogen bond. So iodine would be by itself. Now, to begin with, iodine had 3 lone pairs. But when that bond breaks, iodine will now have 4 lone pairs. Again, oxygen gave up electrons. It's going to be positive here. Iodine accepted the electrons. It's going to be negative there. The overall charges are the same on both sides, neutral overall. And again, we showed arrow pushing in which we always start with an electron source and point to where those electrons are going. Arrows should never start on an atom. They need to start on a lone pair of the atom or a bonding pair. And last, we have acetic acid with trimethylamine. Again, we have to find what's our acid and what's our base. We have a hydrogen on a heteroatom, so chances are that is a protic source, a proton source. So that's going to be our acid. And our base is going to be over here. The nitrogen is going to accept accept a hydrogen because it has electrons it can donate. So let's go ahead and draw that arrow. Now again, this hydrogen is going to be transferred. So I want to redraw this showing that bond because I need arrows showing that the bond is breaking. Our base is going to bond to the hydrogen. Hydrogen therefore has too many bonds, and we need to break that bond and push those electrons over to oxygen. So when I redraw this, the oxygen at top is the same. The other oxygen is gaining a lone pair, so it goes from 2 lone pairs now to 3. And then the nitrogen is losing a lone pair to form a bond to hydrogen. And if we look at our charges, oxygen gained electrons, so it's going more negative. Nitrogen lost electrons, it'll become more positive. And so these are just 3 examples of acid-base reactions.